Hi guys, welcome to the world of DevOps. Myself Karthik, DevOps trainer or consultant, and then I do have experience of 13 years, and then you can contact me on this particular email address. So this DevOps series is absolutely for free, guys, and then if you like my video, please do subscribe. So let's talk about the agenda for today, and then we'll talk about why DevOps, and then we also see the goals of an organization, and what are the software models that are available in the market, and then when to choose DevOps and when not to choose DevOps, and what are the delivery challenges that are being faced, and then I'll also explain you the architecture of DevOps tools by integrating all of them, and I'll provide you the best life cycle of them out of it. All right, so let's talk about why DevOps, goals of an organization. I mean, before we jumping on to why DevOps, we'll also talk about goals of an organization. The first goal of an organization is fast delivery. So when we say fast delivery, if at all you're not releasing the product fast enough in the market, you are actually losing the customers, right? So you're not compete enough to actually roll out the product with other competitors that are available in the market. So in order to deliver your product faster, right? So you have to adopt something called as some tools called as CI/CD tools. So the best CI/CD tools that are available in the market are like Jenkins, Bamboo, etc. Right? So we'll have to deal with something called as CI/CD tools, which helps us in continuous integration and then continuous delivery or deployment. So when you say continuous integration, we are trying to continuously integrate our code whenever a developer is trying to make a change, and then that particular change is being actually integrated into the var file or the output of what you are trying to generate if it is for Java. The next second goal of an organization is cost. So when we say cost, so each and every organization actually wants to actually save cost, right? The one such example that they can think of is like, let's say your organization is running all the servers on the bare metal servers, you can actually migrate your infrastructure to the cloud. So what benefit I get when I migrate things to the cloud? So one benefit that I get is like no maintenance of infrastructure, and each and everything is being maintained by Azure or AWS cloud. And you need not actually, you also get something called as discount, 75% of discount when you actually reserve the instances, right? So the third goal of an organization is the quality. So when we say quality, if at all you're not releasing the product quality enough, so what happens if the bugs have been introduced when the customers are accessing your websites, you will again lose the customers. They will actually switch to different website, right? If you're, let's say you're trying to book something on amazon.com, and then if you're trying to face some issue at the payment gateway or something, then what does the customer do? He'll feel like he want to switch to the different vendor, like let's say if you Flipkart or any other vendor that actually is available. So one of the best tools that are available in the market for actually measuring your code quality is SonarQube, and then the other tool is like Jekako. So SonarQube is actually code quality tool, which actually has gotten some enough templates on it, and then using those templates, it tries to evaluate your code, right? So how efficiently you have written the code base. Let's say you have written 5 if conditions, and then you can actually switch that to a case statement for better control flow. Rather than flowing, the control is flowing to all if conditions and else conditions. It actually can evaluate with the case statement, which will be fast enough. The other tool is like Zekako. So it is like a code coverage, which means that you have written the code and then you will also write something called as unit test cases. So when you say unit test cases, all of these unit test cases will be validated against your main code, right? So when it will be validated against your Java or main code. So what happens here is like you will feel confident enough with all the use cases, whatever possible use cases that you actually have kept or adopted in the unit test cases, which means that you are confident enough to roll out your product to the market, right? So this tool helps in measuring the code coverage. So how much lines of code that you have written, and how many unit test cases that you have written to validate the code that you have written. So how many lines have been covered with the unit test cases, which means the control has how many lines the control has been flown to measure the actual code that you have written, right? So that's how we actually measure with the unit test cases. These test cases will actually help in measuring the code that you have written. All right. So next thing is like high availability or zero downtime. This is very important, guys, right? So if you are actually having a downtime of your application, what happens? When your application is down, so it's a gate closed for your application or your company for stopping the revenue, right? So revenue is being stopped when you actually maintain the downtime for your application. We don't want to have our application to go down, right? So any organization or any product that we develop, we don't want that to be happening. So one best model that is available for maintaining high availability of your application is called as blue green deployment. So how exactly this works? So for example, you have server 1 and then server 2. Let's say you have deployed a code of V1 version 1, right? So version 1 code has been deployed here and then in both servers, and it has been load balanced with a load balancer. So now let's say you have prepared something called as V2, which is like you have gotten your version being upgraded. Let's say you have added a new feature, so each and every product will have a new features are coming, right? So you'll definitely have to add, or it will be like when you actually compile the code, it will be new versionized. So this new features have been adopted in this particular code. So this code has to be deployed into the servers. So when you actually want to deploy this code into the servers, you have to make these particular servers down. So if you're making the servers down to update the software code, what happens? This code, whatever you have, the servers have been down, then the application will be not accessible. So if the application is not accessible, what happens? Again, you are actually trying to um stop the revenue, right? We don't want that use case or scenario, right? So how we are going to achieve this? So what we have to do is like first we'll have to detach the server and then update this particular server from V1 to V2 and then add it back. Similar way, then again we'll second time we'll detach this and then add it back after upgrading from V1 to V2. So this way we are actually engaging our customers with either of the servers before instead of we completely stopping it. So this mechanism is being adopted in Kubernetes also, guys. Automatically, this particular functionality happens with Kubernetes. So Kubernetes has gotten the blue-green deployment automatically enabled when you actually do deal with something called as deployment, stateful sets, anything. All right. So now let's jump on to this and see what are the software models available. So the first software model that was available was like waterfall model. The second one was like the second later came as agile and then DevOps model. Let's talk about them. The first model, like waterfall model, this was the first publicly documented lifecycle model, software development model, which was released on 1917s. And then it like, say for example, how you can imagine the waterfall model is like, say for example, you are having a cliff of a mountain. First, you'll be actually gathering the requirements, and then you'll be doing a design of that particular thing, and then you will be doing a coding, and then you'll be like testing and then releasing it to the production. So when we say waterfall model, it's like waterfall model. Like let's say it is trying to fall from first step to the second step kind of thing. So unless and until you have actually gotten complete requirements, you will not be able to move to design phase, right? So you cannot actually go back. This is the drawback. So once the requirements are being gathered, then only you will have to start with the design. Then once you're done, completely done with your design, you have to start with coding, right? So it takes ample amount of time to let's say you are actually in phase of requirement gathering. The people who are actually doing a development team will have to wait for the complete requirement gathering and then design part of it. So it's like most of the time consuming thing. So and it is going to be like we are not guaranteeing, we can also not guarantee that the product can be released faster, right? Because of some, let's say some bugs have been introduced here, again you have to start with, you cannot go back, you have to start to check with the requirement gathering, again designing, and then again coding, and then again testing. So this is the flow that you have to follow, and then end of the day you're not getting the product on time, right? So update version of this is something called as agile. So when we say agile is actually also what happens in agile is like, in agile we first what we do is like let me increase this. So in agile we also have a requirements. These requirements are actually split into smaller chunks of epics. So when you might have also already heard about epic story points and all this stuff, right? Stories and all. So so each and every large requirement is actually split into epics, and this epics each epic will also have something called as stories. So these stories are again prioritized in the sprints. So this how actually things are being managed with agile. So what is that guaranteed here? So it's like you have large requirement that you have split it into smaller chunks of epics, and then each epic has its own stories. And then we here what we are trying to do is like we are trying to prioritize what is the feature that we have to roll out for our application, right? What is the second feature? What is an add-on feature? What is third? We are trying to prioritize, and then slowly we will be doing something called as releases. We are gonna release our product s- in a phase wise. So this way, instead of we promising that the customer that we are releasing the complete product, we are rolling out it in a phases via releases, right? So this way, what happens is like what benefits that we are getting here is faster feedback from the customer. So if at all, whenever we get to see a feedback, let's say this functionality is not working, as it's a smaller chunk, right? So we'll be able to easily go and then redo a design part of it, and then try to do a coding and then release it as a bug fix or hot fix. So as we can actually, as it's a smaller thing, we get feedback faster, and then we'll be able to incorporate that particular change into the process. All right, so this is what agile mechanism talks about, and then but here also we have a challenge where let's say you have dev team and then ops team. Let's say let me write in this way. Let's say you have development team and then operation team, right? Dev and ops team. All right, so now that you are specifying that you wanted to roll out this particular release, right? So release, you have tested this particular release R1 properly, and then you wanted to roll it out to the either dev or the production service. So now what happens is like however you have actually deployed this particular code in your dev environment, it is working fine, right? So you have asked the same thing to do by ops team. So when he is trying to roll out this particular R1, right? R1, what happens? So when he is trying to roll out this particular R1, it looks like the code is not functioning well. So this guy says that I have done whatever you have code you have given, I have deployed it. This guy will say that it's working fine in my local machine or in local environments. There is something which is going wrong with your machines in production. Say for example, in this scenario, what happens is like you have to let's say it's a production server. As it's a production server, the development team will not have an access. You will have to debug, and then ops team has to debug and then get to understand what went wrong, and then finally let's say they have upgraded the java because of from java 8 to 11. Let's say they have done this as part of patching. So because of this version upgrade from 8 to 11, it might have not the functionality that you have developed in 8 is not working well, right? So this is one of the issue that has been faced in order to identify this particular issue, and then let's say it is trying to take some 30 minutes downtime. So you actually have gotten 30 minutes of downtime, and then which is not acceptable, right? So which cannot be acceptable in production. So you'll begin losing customers as we talked about. So we don't want this particular downtime to be there to be there to be faced by any of our customers as well. So how actually we are going to deal with this scenario? So we have gotten something called as automation tools. Let's say in this case we'll be using something called as Ansible. So Ansible is one of the configuration management tool, guys, and then deployment tool, right? It's called as configuration management or deployment tool. So when you say configuration management and the deployment tool, you can actually have a playbook. So Ansible talks about writing something called as playbooks. We'll talk about all of these in detail. So playbook will have something called as instructions, or will have gotten something called as tasks. So first task is to install. Java 8, right? You'll have to install Java 8 and then deploy. Second task is to actually deploy your code of V2, right? So as it's been a playbook, right? We'll just execute the same playbook in the dev environment, and then the same playbook can be executed on ops or production environment as well. So in this way, we are actually promising that our application will definitely work because we are trying to the Ansible has got idempotency. So even if you have 11, it tries to get back to 8, right? And then you'll be able to deploy your code of V2 after installing or ensuring that your Java 8 has been present on the production system. So this was the gap, guys, between I mean, in with agile methodology. So this gap has been actually replaced with the model called as DevOps, right? So now DevOps is nothing but so DevOps is nothing but DevOps is equals to agile plus automation, automation tools. So in so DevOps is nowhere different from agile, guys. So it is DevOps is equals to agile plus automation tools. All right, so let's jump on to the PPTs. So that's what we have discussed. We have requirement gathering, design, and the implementation of coding, and then testing, and then deploying, and then finally we'll be maintaining our code. So disadvantages we have discussed about it, like no software code has been produced until late during the life cycle, high amount of risk if any bug has been found, and we have to again do redesign and redesign and then code again, all of these. So not a good model for the object oriented or complex projects. And if you have a, I mean, if you don't have any changes, then it is best suited. If you have a lot of changes in your requirement, then it's not the best model. Second coming upcoming is like agile methodology that we have talked about. Each is split into sprints, and then each sprint is being prioritized, and then finally testing has been done, and then releasing into the production, and then finally it's been maintained, and we get to see have a faster feedback. So suitability is like requirements get changed moderately. Let's say you have a requirement being changed in order to compete the market. You'll have to definitely adopt new changes, right? So you have to, if, in order to do that, the best model that is available is like agile methodology. But here the limitations are like that we discussed. A lot of conflicts between dev and then operations team, and then this can be actually uh, dealt with one of the best model that is called as DevOps. So DevOps is also called as the software development strategy, model, methodology, practice, and then it bridges the gaps between development and then operation team. By saying this, it means that it participate together in the entire software lifecycle development from design through the product prod support. So advantage is like product can be delivered to clients quickly without any bugs, reliability because of good code quality with all tools that you have integrated in it. So not suited. I mean, it is not specifically for I mean, it's not suited for no moderate changes and something like that. Suitability is like you have gotten the if you have moderate to high changes, this is the model that is being actually best suited for. So here are the DevOps tools, guys. For the plan, we use something called as Jira, and then for the coding, we use something called as Git and SVN. SVN was the old one, so now everyone is on Git. And then for build, we use something called as and then Maven, Gradle. And then for testing, unit testing, JUnit, and then Selenium. And then for deploying the code, we use something called as Docker. And Docker is one of the environment. And then we Vagrant, kind of. We also use to configure them. We use something called as Chef, Puppet, SalStack, and then Ansible. All of these are like configuration management tools, like installation of software, all this stuff. Once you have deployed your code, you'll be monitoring that, right? So by using Elk and then Nagios and then Splunk. So this how we actually, I mean, all these are like individual tools, right? So in order to bring them together, you have to actually integrate, right? So we need some integration tools because you'll be planning, coding, testing, and then deploying and operating and then monitoring. This is an infinite loop, guys. We cannot sustain with the without having, as is an infinite, we cannot sustain with doing slowly, I mean manually stuff. We wanted to have some automation tool with the help of Bamboo, Hudson, or Jenkins. We have these tools helps in these are CI/CD tools, integration tools. which helps in doing continuous integration and then continuous delivery or deployment. All right, so this is one of the real-time architecture, guys. Similar way, like developers will be there, then they'll be developing their code with Eclipse or something, and then they'll be putting their code in the Bitbucket, and then you'll be actually pulling the code and then doing a sonar quality check, and then you'll be building the code, and then unit code coverage will be doing it, and then placing the package in the Nexus, Artifactory, and then deploying it using mapping to the Docker environment. Once you deploy, we have three environments: dev, test, and QA, and then production. So you'll be testing, you'll be enabling all the Selenium app and then SOAP UI testings and then load UI, and then in the performance QA, we'll be specifying all the load UI and then JMeter testings. So on top of it, we have something called as monitoring infrastructure like Splunk and AWS, and then Splunk is nothing but application log monitoring, guys. By looking at the log like, application logs, you'll be getting to understand what went correct and then what didn't go well. So accordingly, you like again raise some create some features and all this stuff, and then during this phase of testing also, I mean the team quality team can actually raise a request and then create a Jira tickets according to fix the issues that they have identified, and they'll allocate to the developers, and then again they'll be working on to fix all of them. It is like an indefinite, infinite loop that never ends. That's all, guys. I'll also explain this particular architecture in another way, in easy mode, where how each and every tool that we talk about, and then where those tools get fit in. It's an upcoming video. So thank you so much, guys, for actually having patience to go through this particular video. Thank you so much. Please do subscribe to my channel for more videos.